Hello children, I welcome you all in my next video. Okay, so let's continue with the same chapter, that is chapter 1, chemical reactions and equations. So we have already discussed three types of reactions, that is combination reaction, decomposition reaction and displacement reaction. Now in this video we are going to do the rest of the two types, that is double displacement reaction and redox reactions. Redox reaction is also known as oxidation reaction. So let's start with double displacement reaction. Double displacement reactions are those reactions in which two compounds are going to be there and they are going to react by exchanging their ions. Now this clearly means, I hope this word is visible to you, by exchange of ions to form two new compounds, which means there are going to be two reactants and there are going to be two products. I hope it is visible that two reactants are there. AB is reactant 1, CD is reactant 2. Then the two products which are formed in this reaction is AD is the first product and CB is the second product. So two reactants are there and two products are there, and the reactants are going to react, these two compounds, they are going to react by exchanging their ions. Now let's say AB is a compound, and if AB is a compound, then if AB is an ionic compound, if AB is an ionic compound, then A is a cation and B is an anion. In the very similar manner, if CD is a compound, then C is a cation and D is an anion. Okay. So now what happens is that when you are going to take an aqueous solution of AB and CD, I hope you remember what is an aqueous solution. Aqueous solution is the solution when you dissolve the substance in water. Okay. So whenever you are making a solution of any substance in water, that is the aqueous solution. So what happens is, okay, so AB when being dissolved in water, then it is going to dissociate into two components or two parts. First one is going to be a cation, so A is a cation and B is going to be an anion. Okay. In the very similar manner, if CD is dissolved in water, it will also dissociate into two components, that is C and D. So C again is going to be a cation and D again is going to be an anion. Okay. Now what happens, these two reactants, they are going to react by exchanging their ions, which means now A is going to be chemically combined with D, and C cation is going to be chemically bonded with B. So this results in the formation of the product, which is AD, and the other product will be CB. Okay. So I hope it is clear to you how come we are getting this AD and CB. Okay. Now we are going to understand the same thing with the help of some examples. So this is the example before you. The first one is a precipitation reaction. Okay. So all precipitation reactions are actually double displacement reactions. Okay. And even the neutralization reactions, where an acid and a base react to form salt and water, that is also an example of double displacement reactions. Okay. So let's just see to it over here. The reactants that we have taken is silver nitrate, and the other reactant that we have taken is sodium chloride. Now we have taken the aqueous solution of these two substances, and when you are going to take an aqueous solution of these two substances, then this silver nitrate will actually dissociate into its ions. Ionization will take place. So silver ion will be there, which is Ag plus, and nitrate ion will be there, which is NO3 single negative. So these two ions are formed. silver plus Ag plus ion, and nitrate ion, which is NO3 single negative. Now when sodium chloride is dissolved in water, it also dissociates into its ion, into its respective ions. The first cation will be sodium ion, Na plus, and chloride ion will be there, which is Cl minus. Now what happens? There is going to be exchange of ions. The cation which is produced from reactant 1 will combine with the anion which is produced from reactant 2. So who is going to combine? Silver ion will combine with chloride ion. Okay, and the next one is nitrate ion. So sodium ion will combine with nitrate ion. Now when sodium ion combines with nitrate ion, the product that you will get is sodium nitrate. And when silver ion combines with chloride ion, then the product that you will get is silver chloride. Okay, so this is how it happens. The exchange of ions will take place. The cation from reactant 1 will chemically combine with the anion from reactant 2. Okay, so this is how exchange of ions takes place. I hope it is clear. Moving on to the next example. Next example is also of precipitation reaction. In this precipitation reaction, you have got a white colored precipitate. White colored precipitate of silver nitrate is formed, silver chloride is formed. So silver chloride is a white colored precipitate, or you can say it is the insoluble mass which is formed as a result of mixing two aqueous solutions. Okay, so silver nitrate is a white insoluble solid substance which is formed as a result of mixing two aqueous solutions. Okay, coming on to the next reaction, next example. Now over here we are mixing sodium sulfate aqueous solution and barium chloride solution. Now what happens is, again the same thing will happen. Sodium sulfate will dissociate into its ions. Cation will be sodium ion, which is Na positive, and anion will be sulfate ion, which is SO4 2 negative. So this is the anion which is present in sodium sulfate. Next is dissociation of barium chloride will also take place. So barium ion will be there, which is Ba2 plus, and the other one is chloride ion, which is Cl single negative. Now what happens? Again exchange of ions will take place. So barium ion, this one, will combine with sulfate ion, and the other ion, which is sodium ion, will combine with chloride ion. So when sodium ion combines with chloride ion, the product that you will get is sodium chloride, and the other product will be barium sulfate. Okay, so just let's have a look at it. Yeah, it is visible. Now this is sodium chloride and this is barium sulfate. Now a white precipitate of barium sulfate is formed over here. Okay, because it is insoluble in sodium chloride solution. So barium sulfate will remain as the solid insoluble substance. Okay, so this is a white colored precipitate which is formed over here. Next example, this is also a precipitation reaction, but in this example a yellow colored precipitate is formed. Okay, so again we have taken aqueous solution of lead nitrate. Now what happens on being dissolved in water? It will also dissociate into its respective ions. Lead ion is Pb2 plus and nitrate ion is NO3 single negative. This is the cation and anion which is there in this compound, which is lead nitrate. Next one is potassium iodide. Now potassium iodide when dissolved in water will give potassium ion, which is K plus, and iodide ion, which is I minus. Now again what happens? Exchange of ions will take place. lead ion Pb2 plus will combine with potassium ion, and the other one, which is nitrate. Nitrate ion will combine with, extremely sorry, potassium ion will combine. I have to tell this to you again. So sorry. What happens is that the cation combines with the anion. It is not possible that two cations will combine. Okay? So I just went the wrong way. So what happens is that the ions which are produced over here from lead nitrate is lead ion, which is Pb2 plus, and the other one is nitrate ion, which is NO3 single negative. Okay? And from potassium iodide what we are getting is iodide ion, I negative, and potassium ion, which is K plus. Now what happens that the cation, which is lead ion, will combine with the anion, which means iodide ion. Okay, so the product that you will get is lead iodide, and the other one, which is potassium ion, potassium will combine with nitrate and will give you potassium nitrate as the other product. Okay, so this is how the formation of products takes place in case of double displacement reaction by exchange of ions. One very important thing that I would like to mention over here is that double displacement reactions are actually not dependent on the reactivities of metals. Okay, the way I have told you single displacement reaction or displacement reaction, it was based on the reactivity of metals or non-metals. But over here simply the exchange of ions is taking place and it is not at all related to their reactivities. Okay. Next, in the last example that we are going to take up is an example of what? This is a neutralization reaction. Why is it a neutralization reaction? Because you can see that sodium hydroxide, which is a base, it is reacting with an acid, which is HCl, and the products that you are getting is salt and water. Salt is sodium chloride. Okay. Now when sodium hydroxide is dissolved in water, on ionization what you will get is sodium ion, which is Na plus, and hydroxide ion, which is OH minus. Okay. Then in the very similar manner, when HCl is going to ionize, the two products that you will get is H plus ion, and the other product will be Cl minus ion, which is chloride ion. Okay. Now what happens? Again the same thing will happen, that is exchange of ions. So sodium ion, which is the cation from reactant 1, will combine with the anion from reactant 2, which is chloride ion. Okay. And the cation from reactant 2, which is H plus ion, will combine with the anion from reactant 1, which is hydroxide ion. So H plus and OH minus will give you water, which is H2O, and Na minus and Cl minus will combine to form sodium chloride salt. Okay. So I hope you understand this is how the formation of salt and water takes place. Okay. Chaliye, let's move to the next thing. Now the next category or the next type of reaction is redox reaction. Okay, and redox reaction is also known as oxidation reduction reaction. Now why is it so? Oxidation and reduction are two different things actually. Oxidation is addition of oxygen and reduction is removal of oxygen. Okay, or you can also define oxidation and reduction with reference to hydrogen. So if addition of hydrogen is taking place, then it is reduction, and if removal of hydrogen is taking place, then it is oxidation. So I would suggest, rather than being confused, it is very much a better idea to understand the meaning of only one. What is oxidation? Oxidation is addition of oxygen, or you can say removal of hydrogen. So removal of hydrogen or addition of oxygen is oxidation. Now you can see over here it is written. Now addition of oxygen is oxidation and removal of hydrogen is also oxidation. So either a substance is taking up oxygen, then it is getting oxidized, or a substance is losing hydrogen, then even it is getting oxidized. Any one from both of these is there, then the substance is getting oxidized. Next is reduction. Now reduction takes place when the hydrogen is going to be added to some substance, okay, or what else can happen is that removal of oxygen takes place from a substance, that is also referred to as reduction, okay. So both of these are reduction. Now what is an oxidizing agent? So oxidizing agent is that substance which gives oxygen for oxidation. If you have oxygen and you are going to give oxygen to the other substance for it to be oxidized, then it is an oxidizing agent. So the substance which gives oxygen or which takes hydrogen, okay, what you can do is either you can give oxygen or you can take hydrogen. In both these cases you are going to be referred to as oxidizing agent. And the next and the last one is reducing agent. Reducing agent is the substance which gives hydrogen and which takes oxygen. So oxidizing agent is actually just opposite of reducing agent, okay. Now you will understand this better when we are going to take up few examples, okay. So let's move ahead. Now oxidation reduction always takes place simultaneously. You might be asked that why oxidation reduction always takes place simultaneously. It does take place simultaneously because you can imagine a substance is there which is giving oxygen, okay. So other substance should be there now which is accepting oxygen, and the substance which gives oxygen is going to be the oxidizing agent, and the substance which will accept that same oxygen will be the reducing agent. And as a result what happens, oxidation and reduction will take place simultaneously in a reaction, okay. So oxidation reduction reactions are also called redox reactions because oxidation and reduction takes place simultaneously. Chaliye, now move ahead, let's have a look at some of the examples. Now over here zinc oxide is shown to you. Now zinc oxide has oxygen with it, you can see zinc symbol is Zn and oxygen symbol is capital O. So zinc oxide already has oxygen and it is going to change into zinc metal after the reaction. You can see on the product side it is changing into Zn, which means zinc oxide is losing oxygen. So what is happening with zinc oxide? Is it getting oxidized or is it getting reduced? Obviously zinc oxide is losing oxygen, so it is getting reduced. See, it is written over here, it is getting reduced. Okay? Next, have a look at the other reactant. Now whenever you are being asked to identify the substance which is getting oxidized or identify the substance which is getting reduced, the answer is going to be always there from the reactant side. Mark my words. What did I said? I said that if you are being asked to identify the substance which is getting oxidized, or if you are asked to identify the substance which is getting reduced, it is always going to be amongst the reactants, okay. It is never going to be there from the product side. Product side में से इसका आंसर कभी भी नहीं हो सकता है, ठीक है. Now let's have a look at the other reactant, carbon. Other reactant was carbon and carbon is changing into carbon monoxide. So carbon is accepting oxygen, which means it is taking up oxygen and carbon is getting oxidized. So carbon के साथ में क्या हुआ है? Carbon is getting oxidized. Why oxidized? Because carbon is changing into carbon monoxide and it is accepting oxygen. So addition of oxygen is oxidation and carbon is getting oxidized. Now if you are asked to identify the oxidizing agent and the reducing agent, so it is even more easier to identify the oxidizing agent, the one who has oxygen. Who has oxygen over here in this example? The one who has oxygen is the oxidizing agent, and I guess zinc oxide has oxygen. That is why zinc oxide is the oxidizing agent. ठीक है? And obviously if zinc oxide is the oxidizing agent, then the other reactant which is carbon will be the reducing agent. So carbon is your reducing agent. Okay? This is all about this reaction. Let's move ahead. Have a look at the next example. Okay. Now I have already, the last example that we have taken, that was with reference to the presence of oxygen, addition of oxygen, removal of oxygen. Now in this example, oxygen is not there. You just see to it, oxygen is not there anywhere. Can you see oxygen over here in this example? No. So how we are going to find out the substance which is oxidized, the substance which is reduced, the oxidizing agent, reducing agent, and every bit of it? कैसे पता चलेगा हमें? Now we are going to answer with reference to hydrogen. Okay? जैसे addition of oxygen oxidation है, वैसे addition of hydrogen reduction है. ठीक है? So let's have a look. Who is accepting hydrogen and who is losing hydrogen? So with the help of that, we are going to identify the oxidizing agent and reducing agent. Now H2S is hydrogen sulfide gas, and H2S already has hydrogen, okay, and H2S is going to change into S on the product side, which means H2S is losing hydrogen, okay. So addition of oxygen was oxidation, but removal of hydrogen is also oxidation. So H2S is the substance which is getting oxidized over here. ठीक है? H2S का क्या हुआ है आपका? H2S is the substance which is getting oxidized. I'll write in short, it is OXID, which means oxidized. ठीक है? Next, coming on to the next reactant, let's have a look at the other one, which is chlorine. Now what happens to chlorine? Chlorine is actually changing into HCl, which means chlorine is accepting hydrogen, okay. So the substance which accepts hydrogen or in which addition of hydrogen takes place is the substance which is getting reduced. So chlorine, which is Cl2, is getting reduced. Okay. So chlorine is the substance which is getting reduced because it is accepting hydrogen. Okay. Understood? Now the other part of it, that which is the oxidizing agent and which is the reducing agent. Now let me tell you one shortcut method of doing this. If you have identified the substance which is getting oxidized and if you have identified the substance which is getting reduced, then you just have to do vice versa of this. The substance which is getting oxidized will be the reducing agent. That is your reducing agent, okay. And the substance which is getting reduced, this chlorine, will be your oxidizing agent. This is actually a shortcut method of understanding, okay. So the substance which itself is getting reduced is the oxidizing agent, and the substance which itself gets oxidized is the reducing agent, okay. Got it? Chaliye. Let's have a look at the last example. Now over here, the last one is this one. MnO2 is manganese oxide plus 4 HCl is there, then manganese chloride is formed and chlorine is formed and water is there. Now again, I will say the same thing, that if you are asked to identify the substance which is getting oxidized and the substance which is getting reduced, you just have to look on the reactant side. The answer is obviously going to be there on the reactant side, it is not going to be there on the product side ever, okay, for any of the reactions. So I am not going to tell you the answer of this question, basically it is for your understanding. I have put a question mark, so you will answer me. What I will tell you, I will just hint you the answer of this. Now you can see that manganese oxide is changing into MnCl2, okay, and HCl is changing into chlorine. So now you can tell me the one which is losing oxygen is MnO2 because it changes into MnCl2. So obviously MnO2 will be dash, and HCl is losing hydrogen and is changing into chlorine, which is Cl2. So that is why the substance which is getting dash is HCl, okay. So now I hope you have understood the answer of this question, and you people are going to answer this to me in my WhatsApp group, okay. Next, now we are going to study about some of the oxidation reactions in everyday life. Now few of the oxidation reactions occur in our everyday life, and it is actually a noticeable change. You get to see to it. Those oxidation reactions are very much visible to you, okay. So one of the very common oxidation reaction which takes place in our everyday life is rusting of iron. Now iron is a metal which gets rusted. What do you mean by which gets rusted? Which get rusted means it gets coated with a reddish brown substance, okay, and that is nothing else but rust. क्या होता है वो जंग होता है ना, and this rusting process actually leads to wastage of iron metal. और इसकी वजह से क्या होता है, आपका आयरन मेटल पूरा वेस्ट हो जाता है, इट एक्चुअली गेट्स डिग्रेड होकर ख़त्म हो जाता है ना. सो रस्टिंग इज ऑब्वियसली अ वेस्टफुल प्रोसेस, इट लीड्स टू वेस्टेज ऑफ आयरन मेटल. ओके, another one is rancidity of food. Rancidity I'll be explaining in the next half of this video. Let's continue with corrosion or rusting. So what is corrosion and what is rusting? Now there are two terms. I was telling you about rusting only. Now another term has arrived which is corrosion. Now corrosion is the process in which metals are eaten up by the action of air, moisture or a chemical on its surface. So if any metal surface is being degraded by the action of air, moisture or any chemical on its surface, then the name of the process is corrosion. But if that metal specifically which is getting corroded is iron, then the name of the process will be rusting. Okay, so there is a very minute difference between rusting and corrosion. Corrosion is a general, or you can say a wider word, which is used for metals when they are getting corroded due to the action of air, moisture or a chemical on its surface. And rusting is a word specifically used for iron metal if it is getting corroded due to the action of air and moisture. Okay, so rusting of iron metal is the most common form of corrosion. So rusting is basically a form of corrosion. Okay, let's proceed to the next slide. Okay, now we are going to discuss about rusting. What is rusting? Rusting is the process in which the iron articles get coated with a reddish brown substance due to the action of air and moisture. Now rusting takes place whenever the iron articles or the iron metal is exposed to moist air. It is not just the air which is responsible for rusting, it is the moisture also which is present in air which is responsible for rusting. Okay, and the reaction which takes place in rusting is this: iron metal reacts with oxygen and with the moisture also, which is represented as H2O. Then the product which you get is rust or zang, you can call it in Hindi, and the formula of rust is ferric oxide dot XH2O. Now why is it XH2O? Because the number of water molecules which will be chemically bonded to ferric oxide is not actually a fixed number. That is why we have written XH2O over here. Okay, so this is hydrated ferric oxide. Why hydrated? Because some molecules of water are chemically bonded to this ferric oxide, that is why it is hydrated ferric oxide. Okay, and this is how a metal surface looks like, or you can say iron looks like if it is getting rusted. This is the reddish brown porous mass which forms, and rusting is regarded as a wasteful process because once a layer of iron is exposed to moisture and air, it gets converted into what? Rust, and then that powdery mass which is rust falls off from the metal surface, and then the next layer of the metal is also exposed to moisture and air. Then that also gets converted into rust, and that also falls off from the metal surface. And as a result, what happens with the passage of time, the whole metal is going to be degraded. पूरा का पूरा metal खत्म हो जाएगा. Whole lot of it will get converted into rust. Okay. Next is rusting को prevent कैसे करें? How we are going to prevent rusting? Okay. Just before that, a definition of rusting is also there. Rusting is, what is rust? Rust is a reddish brown porous substance formed on the surface of iron due to the action of air and moisture. So what is rust? Rust is a reddish brown porous substance which is formed on the surface of iron due to the action of air and moisture. So that reddish brown porous substance जो बनता जा रहा है उसी को हम rust बोलते हैं. Okay, and we can protect iron from being rusted. How? We have to do galvanization. I hope you know what is galvanization. Galvanization is the process of depositing a thin layer of zinc. Zn is the symbol of zinc on the surface of iron. So you can by electroplating process, what you can do is a layer of zinc can be deposited on the surface of iron, and layer of zinc will protect the iron from getting rusted. Next thing is painting. You can paint it. You can see in this image, painting is being done on the surface of iron door, maybe it's a door, so that it doesn't get rusted. Now painting the surface actually cuts off the supply of air and moisture, and as a result this rusting process is going to be delayed. Okay. Next is greasing and oiling. Now applying a layer of oil on the surfaces, applying a layer of grease on it. Now grease is actually a lubricant. You must have seen whenever you give your vehicles for servicing, then you must have seen that they put a layer of oil into it, they put some grease into the automobile parts. Now what is the purpose of doing it? The purpose of doing it is to protect the automobile parts from being rusted, because if the part will get rusted, then there is going to be more friction in between the particles, in between the automobile parts, and more amount of energy will be consumed. Next and the last one is alloy. So what is alloying? Alloying is the process of what is alloying? Alloying is the process of what is an alloy? Let me tell you first of all what is an alloy. An alloy is a mixture, homogeneous mixture of two or more metals, and when you make an alloy by mixing two or more metals or a metal and a non-metal, then that process is named as alloying. Now what is the purpose of making an alloy? There are different purposes for making an alloy. Maybe while making an alloy you are increasing its electrical conductivity, while making an alloy you are protecting it from being rusted. Okay. So different purposes might be there for alloying, but over here you can make an alloy of iron so that it doesn't get rusted. And I hope you know there are two alloys of iron. First one is steel and the second one is stainless steel. Both of it doesn't get rusted that quickly. Stainless steel doesn't get rusted at all, and steel does get rusted, but not to that extent as far as iron is concerned. Okay. Okay, so let's move on to the next thing. Rancidity. This is the last topic from this chapter. So what is rancidity? This is also a common oxidation reaction which takes place in our day-to-day life. Now what happens in rancidity is that food items, edible items, okay, which contain some oil or fat, when it is left open in moist air, then what happens? Then the oil which is there present in the food item, it actually gets oxidized. And oxidation of fat and oil, whatever is present in your food item, leads to a very bad smell and unpleasant taste also. Okay. So if the food is going to turn rancid, then you won't be able to consume it because of the unpleasant smell and taste. Okay. So this is how it happens. Now coming on to the definition of rancidity. Rancidity is the condition produced by aerial oxidation. Now what do you mean by aerial oxidation? Aerial oxidation means when the oxygen is taken up from the air or from the atmosphere, then it is aerial oxidation. So oxidation of fat and oil which is present in food takes place, and it is marked by unpleasant smell and taste. So the taste of the food item is going to be spoiled, and even the smell is also going to be very much foul or unpleasant, you can say. Okay? Now the question arises, how to protect your food from getting rancid. Now all the food items doesn't go rancid. Only that food item which has some fat or oil content will get rancid, because oxidation of fat and oil is only taking place. Okay? And actually rancidity is different from spoilage. Spoilage involves the microbial action and that, but rancidity has nothing to do with the microbial action. Okay? Now the question arises, how you can protect your food from getting rancid. So you can protect your food by from getting rancid by adding antioxidants. So antioxidants, they are added into packaged food material so that it doesn't get rancid. Now another example is nitrogen gas. You must have seen those chips packets are actually filled with nitrogen gas, and when the chips packets are flushed in with nitrogen, then it doesn't comes in contact with oxygen, and if it doesn't comes in contact with oxygen, then the oxidation of fat and oil which is there in the chips will not take place and it will not turn rancid. Okay? Next is by keeping or storing the food in refrigerator. Now storing the food at low temperatures also slows down the oxidation process. So, this also retards or will not let the rancidity process to be that quick. Next is storing in airtight containers. So, when the food is stored in airtight container, that also doesn't allows that much of oxygen to come in contact with the food item, and that also retards this rancidity process. Next is storing away from light. Now, in dark also the rancidity doesn't take place. So, that is why you can store the food item in away from light, or you can say in dark. So, that is why how it can be protected from getting rancid. That is all about in this chapter. I hope you people have understood it to some extent, and if you have any queries, please feel free to send me your queries. I will be actually very much happy if you will come up with your queries. Okay? Thank you so much.